Welcome to Emelac Online Tutorial. Now before us is this topic, and it says here moment and equilibrium of forces. Alright, in this video we're actually looking at what moment is and what equilibrium is, and how does these two terms relate. Okay, alright, so and I've actually drawn a knot being hooked up with a spanner, and two guys sitting on a seesaw. Now we're using these two pictorial diagram to illustrate what moment and equilibrium of forces is. Alright, now let us start with this first one. Now here is a spanner being hooked up with a knot. Okay, now at this point here there's nothing like a moment. Now but at the point when a force is being applied on the spanner, let's say to this point, tends to move down, so this force is being applied here. Now it's most likely that this knot here will also rotate, now which probably will move up like this. Okay, so now this force has actually caused this knot, okay, to rotate. Now take also the distance now this distance, okay, now the distance here, which actually takes the distance of the spanner, helps in the rotation of the knot. Okay, so as this force is being applied downward, now the knot tend to rotate upward. Okay, so now at this point here, now it implies that without this force being applied right on the spanner, it means that this knot will not what rotate. Okay, all right, now to this point, now we can now introduce what we call moment. Okay, now moment is that force, okay, now that is being applied to an object that will cause it to rotate. Okay, so which we can now say here that moment is defined as a force, okay, that can cause an object to rotate with respect to its perpendicular distance from the points of rotation. Okay, so and here is it. So this is just a simple definition of moment. Okay, and we can just go as saying that moment is the product of force and the perpendicular distance from the point. So at this point now, so here is it. Now the force, okay, which is a product of the distance causing this knot to rotate. So which implies that without this force, then this knot here will not rotate. Okay, so which means applying this spanner with this distance from this point, there will always be a moment as long as the body can rotate. Okay, so let us now move to the seesaw. Okay, this guy, let us mark A and mark this guy B. All right, now let us assume that this guy has a weight of, let's say, 500, and this one 250. Okay, Now, and let us take note that moment actually deals with what? Force, I mean, product of force and what? Distance. Okay, so to this end now, we can actually make something like this, that moment equals what? Force times what? Distance. Okay, so which also implies here that if we are to make force the sort of formula here, we say that force equals what? Moment over what? Distance. Okay, so which implies here that force is directly proportional to what? To moment, and inversely proportional to what? To distance. Okay, which implies that for us to have a greater force, okay, in relation to moment, we will have what? A smaller what? Distance. Okay, so to this end now, if this guy win 500, okay, sit at this point, for it to be balanced with 250 of this guy, it means that the distance of 500-gram guy from this point, oh, okay, will be smaller. Let's say this distance here, distance, okay, distance, small, equals to small. Okay, then this distance for, let us say, d1, then this d2 will be what? Big. Okay, so which means for this seesaw now to be balanced, it implies that this guy with a weight of 500 Newton will have a small distance from this point of pivot with, in relation to the guy of 250, okay, having a bigger distance from the point of what? Pivot. Now, how does this now align with moment and equilibrium? I've just summarized that. Now, for this seesaw now to be in equilibrium, it implies that the moment of this guy, because the moment of this guy must correlate with the moment of this guy, which is B. Okay, the moment of this guy will correlate with the moment of this guy. So there we have what we call equilibrium. So which means at a point where moment equals 0, there we have what? Equilibrium. Okay, so at the point where moment of a system is 0, then there we have what? Equilibrium. So which means if no force is applied here, this knot will not rotate. Okay, which probably gives this O feature here in equilibrium. Now, at the same point here, if this force in relation to the distance is the same as the force on 250 with relation to, sorry, if the moment, rather, the moment between 500 Newton of this guy and the distance from the point is the same as that of 250 and d2 from the point of our pivot here, there we have what we call what? Equilibrium. Okay, so in essence, we now look at the relationship between moment and equilibrium using this particular principle. So the principle of moment in relation, principle of moment, moment in relation to equilibrium. Now, and this principle states that in a system where there is equilibrium, where there is equilibrium. Now, the clockwise moment okay, must be equal to the anti-clockwise moment. Okay, so in this case now, it implies that when the moment of a system is zero, there we have what we call equilibrium. Okay, so how then do we look at what we call the clockwise moment and anti-clockwise moment? So let me probably use a seesaw also again as an example. Now let us consider these forces, okay, on this meter rule being mounted on a pivot or a knife edge. Now looking at these four forces, this F1, F2, F3, F4. Now x1 is the distance of F1 from the pivot. X2 is the distance of F2 from the pivot. Same thing as x3 and x4. Okay, now, so how do we tend to balance the system? Now take note, initially I said that moment is the product of what? Force and distance. There's a moment here. Okay, moment equals force times distance, right? Okay, now let us now look at now, and in a system where there's equilibrium, the clockwise moment must be equal to the anti-clockwise moment. Now the question is, what is clockwise moment here and what is anti-clockwise moment here? Now for simplicity's sake, let me draw a clock. This 12, 6, 3 and 9. Okay, so probably this is the shorter hand and this is the longer hand. Now normally the movement of this clock always goes like this, okay, like this, okay, like this, right, like this. Okay, now this normal movement of the hour clock, okay, is called the clockwise moment. I mean the clockwise movement, or the clockwise movement, not moment this time around. The clockwise what? Movement. Now what if, and we know anything that goes against the normal, it can be called opposite or anti, right? Okay, in this case now, if this is the normal movement called, so if this normal movement is called the clockwise, what if it now goes like this? So it implies that this one goes against the normal, so we can call this one anti-clockwise. Okay, so we've now established the fact that moving this way, okay, is called anti-clockwise, and moving upward is called anti-clockwise. I repeat that again. Moving downward is called the clockwise, and moving upward is called anti-clockwise. All right, now let me use this clockwise movement, clockwise movement and anti-clockwise movement to explain this system of moment and equilibrium of what? Forces. All right, so in this case, so here this force is actually pointing downward, so which means this force will act downward. Okay, now this force is acting upward, so it means if you probably tend to pull, now you want to pull this meter rule upward. Okay, so this one is going upward. Okay, now let's come to this side. This one also F4, right? Now if you are to tie a rope now and pull yourself, this one move downward, right? Okay, so in the same vein, this guy F3, if you are to put your rope here and pull, you will move upward, right? Okay, so here now this is clockwise. By the illustration I gave with the clock, this is what? Clockwise. Now this one's under what? Clockwise. Now this one now, which is now moving up, against the normal movement of the clock, this is called anti-clockwise, and this one is also under anti-clockwise. So we have two forces here acting clockwise, and we have two forces here acting anti-clockwise. The first one, F1, and the second one, F4. Now the ones acting anti-clockwise, the first one is what, F2, and the second one is what, F3. I guess, sorry, the first one is F2 and the second one is what, F3. Now how then do we balance this system? Now using this principle. Now first of all, let us resolve the clockwise moment. I take note, moment equals what, force times what, distance. So but in with regard to this system or this tutorial, we'll be making use of what, x. Okay, now the first equilibrium, the first moment here is force, F1. So the first one is what, F1 times x1. Okay, and it's very important that you tend to sum up all the whole. Take note, the total clockwise moment, sorry, I could have written total clockwise moment here, sorry, total clockwise moment must be equals to the total anti-clockwise moment. Sorry for that slight error or mistake. So the first one, F1, the distance from the pivot, x1, then plus. Now the second clockwise moment, which is what, F4, will now be F4 then x4. Now take note here, it says must be equal to the anti-clockwise moment, must be equal. Now to the anti-clockwise, the first one here is what, F2 x2. Okay, now plus F3 x3. Okay, so here is the moment. So this is the moment, anti-clockwise moment, the sum of anti-clockwise moment, sorry, the sum of clockwise moment, which is equal to the sum of what, anti-clockwise moment. Is that clear? So the whole system can also be 0 by saying F1 x1 plus F4 x4, bringing the moment of F2 x2 and the moment F3 x3. So here you can say minus to the right hand side, to the left hand side, you have F2 x2 minus F3 x3, all equals to what, 0. Okay, so this is just the summary of what moment and equilibrium of forces is and how they are what, being related. So with this formula, you can use it to solve any moment and equilibrium of forces problem in physics. Thank you, and please do share this video to other learners. Welcome to EMILAC Online Tutorial. Before us is this question in moment and equilibrium of forces, and it says here that a uniform beam, which is PQ, that is from here to here, which means it's uniform, now of mass 20 gram. So for the fact that it is it has a mass of 20 gram, which means the center of gravity here is what, 20 gram. Okay, because that is where the weight, the mass concentrates, and length 5 meter, which means from here to this point, from P to Q, is 5 meters. So let me quickly do that. Is 5 meter. Okay, as shown below. Okay, now a man of weight 800 newton. So this guy here, so the weight is what, 800 newton, stands on M. Okay, it's actually standing, but I drew it sitting down, all the same. Now such that QM, that is, okay, this is at M. Okay, let me just make it let me get rid of your head. Okay, let me just say it's like this, standing. Okay, so at this point here, it is M. Let me write your M here. So from M to Q is 2 meter. Okay, all right. Now the reaction P and Q respectively are what? Now first of all, we should understand what reaction is. Now according to the third law of motion, now it says that action and reaction are equal and what? Opposite. Action and reaction are equal and opposite. Now for the fact that P and Q is reacting, it definitely means there is an action on them that is making them to what? React. And this action is being taken, is done by the mass of the beam and the weight of the man. Okay, so but this mass here, since we are dealing with Newton, and so its weight then will become 200 Newton. Why? Because force, sorry, yeah, that is the Newton, or the weight equals what? Mass times acceleration due to gravity. So here we actually did 200 times 10, which will give us what? 200, sorry, 20 times 10 will give us what? 200 what? Newton. And that's how I got this 200 Newton. Okay, now take note that for it to react, it means they will be acting upward. Okay, so both P and Q act upward because they are reacting to the downward push of what? 200 Newton of the weight of the beam and 800 weight of the man standing on the beam. Okay, all right, so take note, from 800 to Q is 2 meter, which means from P to Q is 5 meter, and this 200 here, which is actually the mass from 20, acts at the center 0. If it acts at the center, it implies that from here to here will be 2.5, since from P to Q is 5. So from P to O is 2.5 because it's acting at the center. And if from P to O is 2.5, it also implies that from O to Q is 2.5. And from the question, from the man standing to Q is 2 meter. Definitely the remaining part here will be 0.5. I hope you are following. Okay, now let us now take moment. Okay, take note, we are looking for the reaction of what? P and Q. Now let us take note that the reaction of P, the sum of the reaction of P and Q must be equals to the downward action of the weight of the beam and the weight of the man standing. So we can say that P plus Q must be equals to 200 plus what? 800, which then become that P plus Q equals 1000 Newton. Now, but we need to find P and Q. Okay, first of all, let us take moments about let us say Q. Okay, which means we are actually driving our moment towards what? Q. Okay, now if we are taking our moment about Q, so we can say here that Q, okay, times the distance. Okay, no, sorry. Okay, let us take from P. Let us take from P. Okay, then our Q from P is 5 meter, right? So then the moment of Q from P will now be Q times 5. Now take note that the moment equals to what? Force times what? Distance. Okay, and the reaction of Q against this beam is in force, and the distance from P, because we are taking moment about P, is what? That the distance from P to Q here is 5. Okay, so and it must be equal to the total of 200 to P and 800 to P. So here we have 200, which is the force, times what is the distance between 200 and P is 2.5, then plus now 800, then times the distance of 800 from P is 2.5 plus 0.2, so that will be 2.5 plus 0.5, that will be 3. Okay, so here we have what? 3.0. Okay, so to that end, this will now be 5Q. 200 times this should be 200 times 25 over 10. I'm putting it in fraction because I don't have calculator at the very close to me here. Now 3 times 800 here will give us 2400. Okay, so 0 here, 0. So here we have 5Q, then equals 20 times 25. So which means 20 times 25 will give us what? 50. Then plus our 0, that will be 500. Then plus 2400. So here we have 5Q, then equals to 500 plus 2400 will give us what? 2900. Now divide both sides by 5. Now 5 here, 1. 5 in 29, that should give us 5 in 29 should give us 5. That will be 5, right? Then remainder 4. So you bring down 4 to this 0 here. In 40 here you have what? 80. Then in 0. So this will eliminate this. So Q, the reaction of Q is what? 580 Newton. Now let us recall here that P plus Q, which is the upward force, must be equal to the total downward force, which is what? 1000 Newton, according to my formula here. So here we have that P equals Q is what? 580, then equals 1000, then subtract 580 from both sides. So we end up having that P, because the whole of this now will give us 0. This is 2, I'm sorry, this is 0, this is 2, then this is 9, 4. So P equals to 420 Newton and Q equals to 580 Newton. So these are the reactions of P and Q on the beam. If you love what I've just done, kindly subscribe to my YouTube channel. Welcome to Emelak Online Tutorial. Now let us look at this question in moment and equilibrium of forces. It says a meter rule is found to balance horizontally at the 48 centimeter mark. Okay, which means the mass of the meter rule rests at what? 48 centimeter mark. Now when a body of mass 60 grams is suspended at the 6 centimeter mark, the balance point is found to be at the 30 centimeter mark. Calculate the mass of the meter rule. Number 2, distance of the meter rule point, distance of the balance point from the 0 end if the body were moved to the 30 centimeter mark. Alright, let us represent this pictorially. So this is the meter rule, and we are told it is balanced at what? 48 centimeter mark. So let's say here is our 48 centimeter mark, which makes the meter rule 48 here, 48 here. So you have 48, which means from here rather to this point here is 48 centimeter. Let's make it here 0. Okay, so which also tells us that here is the mass at this point is the mass of the meter rule. And also we are told that when a body of mass 60, now let us assume here, now mass 60 here, okay, this is 60 gram, now is suspended at 6 centimeter. So which means from this 0 point to this point at which the mass or the body is being hung is 6 centimeter. Okay, and we are told that the balance point is found to be, so this setup now is balanced if the pivot, let's make it here, so from this point 0 to where the pivot is 30 centimeter. Okay, all right, now we are told to find the mass of the meter rule. Now here is the mass, okay, of the meter rule. Now let us calculate the distance. Now take note, if from this point to the point of the pivot is 30, and from the point 0 to where the mass 60 gram is hung is 60, definitely the remaining part here will definitely be 30 minus 6, which will give us what, 24. Okay, all right. And if from 0 to m is 48, and from 0 also to where the pivot is 30, definitely the remaining part here will then give us what, 18 centimeter. That's because 48 minus 30 will give us what, 18 centimeter. Okay, all right, so at this point now let us find the mass. Now we'll be taking moment about the pivot. Okay, and take note that moment equals force times what, distance. Okay, so we have to take m, which is the mass that we're looking for, then times the distance 18. Okay, somebody just asked me, this actually is meter, I mean is the moment, is different from this m. Okay, this m here, let me just put g so that you won't get mistaken. Now this is the mass of the meter rule. Okay, now so which is mg here, then times the distance, which is from the pivot, which is what, 18. Okay, now this force here also can be related to what, the mass. Okay, the force in this stance is actually mass times what, acceleration due to gravity, which is also the weight. Okay, all right, so then that we have it, then equals to taking this mass here, which is 60, times the distance from the pivot, which is 24. Now at this point now we'll find the mass of the meter rule. So we divide both sides by 18. Now 18 here we eliminate here, so here 3 here is 6, 3 here is 8, 6 here 1, 6 here 10. So we're left with that the mass of the meter rule mg equals 10 times 8, which is what, 80 gram. All right, that's that. Now the next one says the distance of the balance point from the 0 end if the body were moved to the 13 meter mark, which implies that this body is 60 gram. Instead of it being 6 centimeter from the 0 point, okay, or from the 0 end, now it is now being adjusted to 13 centimeter mark. Okay, so let me actually have, we need to have another diagram entirely to this. So we have this diagram here. Now here is the meter rule from here down to wherever it is, and here is the center. Okay, and why I actually make it more bigger is for us to understand it better. Okay, because the same distance from 0 to 80 is also the same distance from 80 to the end here. Okay, so but I just want to make it clear as for us for a better understanding. So now the 60-gram body has been adjusted to 13 centimeter mark from the 0 end. Now it also implies here that, take note that from 0 end to this point, which is the balance point, is 48 centimeter. Okay, it also implies here that this pivot will definitely be adjusted. Yeah, and to that end, we don't know the distance from 60 to the pivot. Let us make it A, and from the pivot to 80, let us make it what? B. Okay, all right. So to this end now, we are asked to find the distance of the balance wire from here to the 0 end. So we are actually looking for 13 plus A. So this is the distance that we're looking for. Let us make it let us say D equals to that is 13 plus what? A, which means from 0 to the pivot. Okay, let us make it as D, which means 13 plus A. Now we don't know A. Now how then do we start with first? Now take note, let us look at it that from 0 to 80 here is 48, which implies that 13 plus A plus B should give us what? 48, right? So let us have that here, that 13 plus A plus B must be equal to what? 48. Okay, all right, that is the total distance. Now let us also take moment about the pivots, which also gives us that this is clockwise moment and this is anti-clockwise moment. So here we have that 80 times B then equals to 60 times A, right? Okay, so to this end, since we are looking for A here, let us make B the sort of formula here. Now dividing both sides by 80. Okay, so here we have 80, eliminate 80, this 0, eliminate 0 here. 2 here is 3, 2 here is 4. So here we have B equals 3A all over what? 4. Let's say this is equation 1 and let's say this is equation 2. Now since we are actually looking for A to help us find the value of D in this equation here, let us plug in equation 2 to equation 1. So here we have 13 plus A plus 3A all over 4 all equals to what? 48. Okay, now let us multiply 4 to both sides so that we now have a linear equation. So here we have, that will be 4 into 13 plus A plus 3A all over 4 then equals 4 times what? 48. Okay, so this hand 4 times 13 here will give us, this will be 252, then plus 4A, then plus, now this 4 when multiplied by 3A over 4, let us say this 4 will eliminate this 4, so we are left with what? 3A, then equals to what? 4 times what? 48. Okay, so here we have 52 plus 7A, then equals 4 times 48 will give us 192. Okay, so here we have 52 plus 7A then plus 192. Then let us subtract 52 from both sides. So here we have that 7A will give us 192 minus 52, which will give us 140. Now there we have that divide both sides by 7, So our A will then give us 20. Okay, but take note, what we're looking for is D. So the distance from the 0 end, take note that D equals 13 plus A, and our A is 20. So let us just plug in the 20 here. So that will give us what? 33 centimeter mark. Alright, so the distance from 0 to 60 here, the body mark at the body 60 gram, which is marked at 30 centimeter from 0 point. So will then be, sorry, that'll be from here to here, will then be 33 centimeter. Okay, so and if it's 13 centimeter, our B here, that'll be 48 minus 33 will give us, this is 5 and this is 1, right? Okay, so here will then be what? 15. Alright, if you love what I've just done, can you subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you and God bless you.